In part 2, we'll explore the chain rule, which is going to be our way of taking derivatives of composite functions. So if we have a composite function that we want to take the derivative of, so we want to find the derivative with respect to x of f of g of x, what you're going to do is you're going to take the derivative of the f of the composite function with respect to g of x, and then multiply it by the derivative of g with respect to x. I've always found this way it's not wrong, but it's kind of complicated. So using the u notation, it becomes a little bit simpler, this formula. And the idea is that if you want to find the derivative of y with respect to x, you find the derivative of y with respect to u, and then multiply that by the derivative of u with respect to x. So this is the way I prefer to look at it. All right, so let's try to use this chain rule. We looked at this example earlier, and we already decomposed it. We want to find the derivative of y equals x minus 1 to the third power. Let's use the chain rule to evaluate this derivative. All right, so remember our chain rule is dy dx is dy du times du dx. So we need to rewrite this function in terms of u. So we're going to say y is just equal to u cubed. So we just make this thing here u. And so u is just x minus 1. So that means dy du, well, actually, let's go back for a moment. So if y is equal to u cubed, right, if y is equal to u cubed, the derivative of this with respect to u, you just drop the power down. So it's going to be 3u, subtract 1 from the power, and that's 3u squared. But remember, u is a variable we created. It wasn't given to us in the original problem. So just take the x minus 1, remember that's what u is x minus 1. We'll plug that in for u. And so we get 3 times x minus 1 squared. All right, so that's what dy du is. But we also need to know what du dx is. Well, let's see, u is equal to x minus 1, and if we want to take the derivative of that, the derivative of x is just 1, and the derivative of 1 is 0. So du dx is just 1. Okay, so we have our two parts here. I should have circled the 2 in there as well. And we'll multiply that using the chain rule. So dy du is just 3 times x minus 1 squared, and du dx is just 1. Multiply those together, and we get that dy dx is 3 times x minus 1 squared. Okay, let's do a couple more examples. Let's find the derivative of y equals x squared minus 6x plus 2 to the 50th plus 10. So recall that's the chain rule. We want to break this down. Well, this thing here is going to be u. So we can say y is equal to u to the 50th plus 10. And then u is just that whole expression, the x squared minus 6x plus 2. Let's find the derivative of y with respect to u, and also the derivative of u with respect to x. So the derivative of y with respect to u, drop the power down, you get 50u to the 49th power plus 0, because the derivative of 10 is 0. Let's plug back in what u is. So instead of 50 times u to the 49th, we'll just say 50 times x squared minus 6x plus 2 to the 49th. Because that's u. And then let's also find the derivative of u with respect to x. So let's see, the derivative of x squared is 2x, and the derivative of negative 6x is just negative 6, and the derivative of 2 is just 0, because the derivative of any constant is 0. All right, so now we just need to multiply the dy du and the du dx to get dy dx. So dy dx is going to be 50 times x squared minus 6x plus 2 to the 49th times 2x minus 6, because this part here is our dy du, and this part here is our du dx. Okay, let's do a couple more here. Well, first let's show this rule called the extended power rule. The extended power rule really isn't a separate rule. It's just a special case of the chain rule that happens very frequently, so frequently that it has its own name. It's called the extended power rule. And the idea is that if you can rewrite your function, y, as u to the nth power, where u is some function of x, then to find the derivative, you just use the power rule. It's going to be n times u to the n minus 1, but because of the chain rule, you also have to multiply that by the derivative of u with respect to x. Okay, so let's do an example here of the extended power rule. The idea, remember our extended power rule, is that if we have y is equal to u to the n, then dy dx would just be n u to the n minus 1 times du dx. All right, so let's do this. We can look at this whole thing, and the inside here is u, so in other words, y would just be equal to 8 times u to the 100th power. So to find the derivative of this, we're just going to use the extended power rule. The 8 stays in front. We're just going to drop the 100 down. 8 times 100 is 800, so let's just write that. And it's going to be u to the 100 minus 1 power, which is 99. And then we want to multiply this by the derivative of u. I'll just write that in derivative of u here. Okay. Let's get rid of all the u's. So we have 800. Instead of u, we said u was just this thing. U is just 3x to the 5th minus 2. So let's write that in for u. 3x to the 5th minus 2 to the 99th power times du dx. Well, if u is 3x to the 5th minus 2, then du dx, the derivative of this, let's see, would be, the 5 would come down, so this would be 15, parentheses here, 15 x to the 4th minus 0, because the derivative of a constant is 0. Okay, so this is the final answer. This is correct, but we could rewrite this a little bit prettier. Let's see, 800 times 15, let's see, what would that be? Well, 800 times 5 would be 4,000, and then times 3 would be 12,000. So we have 12,000 in front, x to the 4th, times the 3x to the 5th minus 2 to the 99th power. Because the idea is multiplication can be done in any order, so we can move the 15x to the 4th in front. So there we go. All right, let's do one more example, which will be a pretty good example of a complicated chain rule question. So let's find the derivative of y equals the square root of 6 times 5x minus 9 to the 3rd power plus 2. So let's start off by using the chain rule, and I'll rewrite this where this whole inside here is u. So therefore, y is just equal to the square root of u, which is the same thing as saying u to the 1/2 power, where u is just all of that in the inside. So let's find the derivative. So dy dx is the derivative of y with respect to u, so that's 1/2 u, which was all of that complicated stuff, to the 1/2 minus 1, which would be negative 1/2 power. And then we have to multiply this by du dx. So if all of this is u, let's see here. We want to multiply this by du dx. Oh wait, this is going to be a little bit complicated. So we want to find the derivative of 6 times 5x minus 9 cubed plus 2x. So we want to find the derivative of all of this. The reason why I'm writing this like this is because you realize that this is actually a little bit complicated and we might have to do the chain rule again. So let me pick a different color here so I don't get confused on my steps. So now we have a new u, and this is our new u. We can call it u2 to prevent confusion, but because I use a different color, I think I'll be okay. So I want to take the derivative of this part here, and I can treat this like the chain rule and do the chain rule again. So now let's rewrite this. So we have 1/2 6 times 5x minus 9 cubed plus 2x. And I want to multiply it by the derivative of this. But it's going to be the derivative of 6u to the third. So that would just be 18u, and our new u is just 5x minus 9. Subtract 1 from the power times to the second power. Times du dx, and the derivative of 5x minus 9 would just be 5, plus the derivative of 2x. And the derivative of 2x, that's pretty straightforward. That's just 2. That should be a multiplication over here. And we can simplify this a little bit. I ran out of space, but maybe I can squeeze it in here. Left off a negative 1/2 power as well. All right, so we have, let's see here. We're going to have 1 over 2 times the square root of all of that, 6 times 5x minus 9 cubed plus 2x, times all of that, times, let's see, 5 times 18, that should be 90, I believe, 5x minus 9 squared, plus 2. And actually we can simplify this a little bit more, but I've run out of space at this point, where we could take the 90 and the 2 and divide it by the 2. So let's change the color. Let's use purple. So this 2 could cancel out with this 90 and give me 45, and cancel out with this 2 to give me 1. So that's our final answer. It's not pretty, but that is correct.